So again, to reiterate from the other video, being in the center of the string does not mean that these two surfaces exist within the actual recursive interiors of necessity. The information exists on the surface and is virtually represented recursively. So really it represents two disparate locations, point B of string, point A of string, both A and B being two separate manifolds entangled, represent the beginning of the string, the potential and the beginning, once they come into relative to each other, of recursion occurring on both sides. So it merely shows that information of the recursion first begins, and recursion cannot begin unless this first cause occurs on the surfaces of the manifolds. So the beginning of the string, or of the sides of strings, just merely represent that information first emerges as a prelude to the recursion and exists on the surface before any recursive functions or the recursive mechanism emerges in their virtual interiors. However, due to being entangled, the two mirrors interact with each other's interiors via recursion. The information implanted on the screens, just if an outside observer will see the sphere ball, which is black on this side and white on this side. The right mirror will reflect the black side, the left mirror will reflect the white side on their surfaces. That's the state of information on the surface. That you have this, the symmetry of the, and I'm going to say symmetry in quotation marks, the symmetry of the real object between the mirrors is divided. One side reflects half the symmetry, the other side reflects the other half. But the two half symmetries of right and left sides, as merging, they merge in representing the full object in the center. So the information implanted on the screens looks just like half of the quantum information on this side and half the quantum information on this side. But the whole of the half symmetries, half symmetry times half symmetry, forms the whole symmetry of the real object. And we'll refer to this in the constraints that we're speaking about as the quantum information, the quantum part of the open part of the string. So if one were to look at both mirror surfaces simultaneously, if a mirrors are set here and I'm looking at both mirror surfaces simultaneously, then I'm observing and can mathematically measure that one side is reflecting half the particle and the other side is reflecting the other half of the symmetry of the real particle, or i.e. the real object station between them. So by looking at both surfaces from this vantage point, or in this way, then you can discern that the whole of the symmetry of the particle, we can discern what the whole of the symmetry of the particle is, even though we can't see the particle. In other words, if the open side of the string is the dark energy side that we can't see, we can get an understanding of that symmetry, or of that energy, or of that entity, condition, volume of invisible information. We can deduce what that information would look like if we could see it, because we can take the two sides, put them together, and view the symmetry in an observable, measurable way, i.e. mass holographic information. By studying these two sides and seeing their relationship as two halves of symmetry, then we can determine, even though we can't see what the real object would look like if we could see it. In other words, we don't need to see the open part of the string so long as we have the closed parts of the strings reflecting parts of the open part of that string. So the whole symmetry of the particle information, is derived from half times half symmetry of the relationship of the mirror-to-mirror entanglement. The information on the surface here, the information on the surface here, combined, studied, observed, measured, experimented with, would dictate the nature of the quantum object itself that we don't see. To put this a little bit easier to understand, if I were looking at the two mirrors, but we're not looking, and part of the state of the experiment was that I'm not able to see the object in between, it's factual that by looking at the mirrors without looking at the object, I can determine what the object is, its symmetry, its condition, the intensity of its light, etc., by just merely looking at the two surfaces themselves. I don't have to see the dark energy to know that it exists due to these emergent geometries on the surfaces or the topology of the manifold. So really, in a sense, and we'll get to this, the whole string relationship that I'm discussing here depicts the spherical or torus relationship, and it's explained via the mirror-to-mirror model that I'm introducing and explaining. So, to a relative observer existing outside the system, in other words, we're looking at the vantage point, we're a relative observer that has the ability to actually get out of this recursive matrix, to exit this recursive matrix at the surface of the black hole, get out of the black hole. In other words, when I say relative observer at this point, we're talking about a relative observer that exists outside, apart from either or mirror, outside and not existing within the interiors of the mirrors, as well not existing at the point of the quantum. In other words, we're a fourth observer. We got a relative observer. Let's just say the real object is a relative observer. Any objects or any object that exists on the surfaces of the manifolds would represent an observer, and all recursive membranes represent individual observers existing down through the recursive lattice. But we're referring to a special relative observer existing outside the whole of this string system. And in that sense, you know, to a person existing outside the system, then that person will be able to discern the information on the mirrors, or that the information on the mirrors looks very similar, if not exactly like, an ordinary particle. But it's not. It's a reflected particle. It's halves of the whole of the reflected particle in the senses of what I've described at this point. So we're going to refer to the surface reflected quantum information as the prime waveform of the particle. And we'll discuss this further on. In essence, again, if we go into light cones and describing this as I did in the initial video with a light source reflecting to a mirror and creating a light ring, then we're going to refer to this prime surface, or this first point event when information was projected to the surface. We can refer to that light ring as a prime, or the predominant wave. It's not the particle. It's the information on the mirrors is not the real object in between the mirrors. It is a representation, an image, a reflection. So we can view it as the main expansion or contraction of information on the surface represents the main expansion and contraction of a wave volume of information existing on a one-dimensional plane. So the subwave, now that's the prime waves. In other words, each manifold has a prime wave, a prime circle. And those circles actually, as we've described, represents two sides of the sphere as existing in between. So here we can go further and extend the analogy by saying that the subwaves exists within the recursive function. So let me check my time real quick. So in essence, the main wave is on the surface, and all other waves, and we'll refer to these waves in the depictions of the mirror-to-mirror recursive as each individual stage of membrane that's asserted into the virtual interior behind whichever manifold we're discussing. So we have the main waveform, and then that's flowing in a different direction and an opposite direction than all the other waves that contracts down from this into infinity within the perpendicular arrow of time. And all of these subwaves are centered basically on the z-axis, which basically is the center of the information on the surface. So the subwaves, recursive, are derived from these surfaces and represent that recursive waves flow in a direction that is opposite or perpendicular to the prime flow of information on the reflected surfaces, reflective of each half of the particle information of the real object existing between. So all recursive flow of information is where the vibrational dynamical states of the string exist. And this is contrary, explicitly contrary, to a smooth flow of information expressed on the surfaces of the respective manifolds that are entangled. So before I exceed, I'm catching myself exceeding the time here, so I'll stop the video here and start another one.